For the introduction, a transformer with a power factor lagging refers to a situation where the electrical load connected to the transformer causes the current to lag behind the voltage in a sinusoidal waveform. For this simulation, we will conduct it using 1 kVA 230 115 T50 Hz transformer with the load of power factor 0.8 lagging. In this objective, we need to determine the impedance characteristic of a given transformer, to determine the voltage regulation of a given transformer for a specific load, and lastly, to determine the efficiency for a given transformer for a specific load.
For Objective 1, the open circuit test and short circuit test was used to determine impedance characteristics such as RC, XM, R equivalent and X equivalent. Firstly, open the files given and calculate peak amplitude by multiply 230 volt with Z2 and we get the peak amplitude V peak equal to 325 volt. By right-click to the component voltage, click the sine function and insert 325 volt of peak amplitude with frequency 50 Hz. Then, 1500 gigaohm was setting in transformer by right-click to resistor R1. The circuit starts to stabilize at the stop time 10 seconds by using transient analysis and 9.8 seconds to start saving the data. After running with 1500 gigaohm, LTSpice was generate voltage and positive current graph. Since the phase current is leading the phase voltage, which means in the transformer, voltage is always leading the current. Hence, we added the trace of the negative current graph and visible graph of the voltage and negative current only. From the graph open circuit test, two graphs was plotted. Given the voltage graph, we obtain the value of the time for the peak voltage TPV equal to 65 millisecond, voltage of the open circuit VOC equal to 325 volt, while negative graph of the current, we obtain the value of the time for the peak current TPI equal to 69 millisecond, and the current of the open circuit IOC equal to 680 milliampere. Phase angle, we can obtain it by using the equation omega times with the delta t, which is the omega. We can use the formula 2 pi f, while the delta t we can use from the value that we get from the graph, which is delta t equal to times at the time at the peak negative current minus with the time at the peak of voltage, and we can get the theta equal to 1.256 degree. From the theta, we can get the value for the RC and XM by using the equation modulus YC equal to current of open circuit test divided by VOC, voltage of the current voltage of open circuit test at the degree negative theta. Modulus YC equal to 680 times with the 10 to the power of negative 3 divided by 325 degree negative 1.26 degree, and we can get the modulus YC equal to 2.0918 times with the 10 to the power of negative 3 minus with the J 4.5863 times with the 10 to the power of 5, and the value that shown that give you the 1 over RC and 1 over XM. So from the value, we can get the RC by inverted the value with the which is RC equal to 1 over 2.098 times 10 to the power of negative 3, and we can get the RC 487.06 ohm. and for the xm equal to 1 over 4.5863 times with the 10 to the power of negative 5, and we can get the xm 21,804 and 0.07 ohm. For short circuit test, we run 1 pico-ohm of resistance without changing the setting of the graph, and we find the phase lagging between voltage and negative current. Hence, we obtain the time of the peak voltage TPV equal to 85 millisecond, voltage of the short circuit VSC equal to 324.65 volt, while negative graph of the current, we obtain the value of time for the peak current TPI equal to 89.2 millisecond, current of the short circuit ISC equal to 144 milliampere. From short circuit test graph, we can get the value of the R secondary equivalence and the H secondary equivalence by using the equation ZSCE equal to VSC divided by ISC angle theta equal to 324.65 divided by 144 angle 36.87 degree, and from that we can get the ZSCE equal to 1.8036 plus J 1.3527, and from that we can get the R equivalent and S equivalent, which is R equivalent equal to 1.8036 ohm and S equivalent equal to 1.3527 ohm. And to calculate R secondary equivalence and the H secondary equivalence, we need to find the A, which is A equal to VRMS divided by turns equal to 230 divided by 150. We can get the 2, value of 2, and then the R secondary equivalence equal to R equivalence divided by A square equal to 1.8036 divided by 2 square. We can get 0.4509 ohm, and the H secondary equivalence equal to H equivalence divided by A square equal to 1.3527 divided by 2 square. We can get the value of the H secondary equivalence 0.3382 ohm.
The second objective is to determine the voltage regulation for a given transformer for a specific load. To find voltage regulation, we can use the first equation. We already have the secondary voltage value, but we have to find the primary voltage from the secondary side. To find the primary voltage from the secondary side, we can use the second equation, but we have to find the equivalent impedance and secondary current first. So we have to use equation 3 and equation 4 to find the equivalent impedance and secondary current. To find the voltage regulation, first we have to find the secondary current. We can find secondary current by dividing the rated power with the rated voltage. The rated power for the circuit is 1000 kilowatt ampere and the rated voltage is 115 volt. So 1000 divided by 115, we will get 8.7 ampere as the value of the secondary current. Then we have to find the value of the equivalent impedance. We can find this value by adding the equivalent R and the equivalent X. So we will get 0.56364 and the angle is 36.87 degree. The third step is to find the primary voltage from the secondary side. We can find this value by adding the secondary voltage with the product of equivalent impedance and the secondary current. And then we will get the primary voltage from the secondary side is equals to 119.904 with the angle of 7.896 times 10 to the power of negative 5 degree. After we calculated all the required value, finally we can calculate the voltage equation. We can find the value of voltage equation with the equation Vp prime minus secondary voltage divided by secondary voltage times 100%. From this equation, we will get the value of voltage equation of the circuit equals to 4.26%.
My name is Muhammad Arif bin Rodin and my metric number is A181265. The third objective is to determine the efficiency of a given transformer for a specific load. The formula of efficiency is P out over P in, which is P out over P in plus P core plus P copper times 100%. Based on the data that we get, the rated voltage is 115 volt, the rated current is 8.7 ampere and the power factor is 0.8. R equivalent is 1.8036 ohm and X equivalent is 1.3527 ohm. The primary voltage is 119.904 and RC is 478.06. Firstly, we need to get P out. We can get P out by using formula Vs multiple with Is multiple by cos theta. For this formula, we get 800.4 watt. The formula for copper losses is Is power of 2 multiple with R equivalent. We will get 136.51 watt. The formula for P core is Vp prime power of 2 divided by Rc. In this formula, we will get 30.07 watt. Since we get all the value, we can get the efficiency. Efficiency is equal to 800.4 divided by 800.4 plus 136.5 1 plus 30.07 times 100 and we get 82.00%. That is our efficiency.
Hi and Assalamualaikum. My name is Najwa Izzati binti Junaidi and my metric number is A182232. So today, I will explain about how to construct phasor diagram based on question that we got. So, from the previous calculation that my friends do, we could determine the value of current secondary, voltage secondary, R equivalent multiplied by current secondary, X equivalent multiplied with current secondary, and lastly, voltage prime over A. To get the value of voltage prime over A, theta, and torque angle, we could use the formula here. And for the theta, since the power factor is lagging, so the value of theta should be in negative. Next, after we listed all of the value that needed to construct phasor diagram, we can simply draw it. So, here is the phasor diagram that we already construct based on the equation that we got. As we can see, R equivalent multiplied with current secondary and X equivalent multiplied with current secondary is perpendicular with each other. Moreover, we also can see current secondary and R equivalent multiplied with current secondary have same phasor angle, which is 36.87 degree, which can refer from voltage secondary because our Vs are our reference angle. Lastly, voltage prime over A constructed from origin to X equivalent multiplied by current secondary. So, this is how we construct the phasor diagram with lagging power factor of 0.8. From the objective, we can conclude that first, impedance values for the transformer is 1.3527 ohm. Second, the percentage voltage regulation of the given transformer is 4.26% and the efficiency for a given transformer is 82.77%. That's all from us. Thank you.